Good morning, sir. My name is Jinath Prasad, second year biotechnology. We are going to explain this group seminar, the topic about haloforms.
Good morning, sir. I am T. Varma from Second Biotechnology, studying in Spaces Degree College. My roll number is 38.
Good morning, sir. My name is Naresh. I am studying in second biotechnology at Spaces Degree College. Today, I want to explain about haloform.
Hi, hi friends. First of all, we are going to telling about haloform reaction. Haloform reaction is a compound, is a combination of methyl or some other halogen compounds. First of all, uh, methyl ketone first we take the mainly ingredient compound is methyl ketone. Methyl ketone is replaced by hydroxyl group. Methyl ketone is replaced by hydroxyl group when we use the reagent is X2NaOH sodium hydroxyl group is attached at is doing a reagent job to converting methyl ketone is converted into OH group. It forms a reagent called hypohalide. Because of it, methyl ketone is mainly used is converted into hydroxyl group when the byproduct is haloform. It is called haloform. By the replace of the reagent, we using the reagent X2 alternate is I2 iodine halide halogen anything is attached to it form hydroform. We use bromine bromoform, and we use chlorine chloroform. First of all, in this reaction we mainly consider this I2 iodine form. In this reaction in laboratories, we adding some chemicals or hydroxyl chemicals, some other chemicals we using. The product is yellow color precipitate. It confirms the methyl ketone is present in this group. So we using the methyl ketone is converted into hydroxyl group. How? First of all, we using the methyl ketone is polarized at hydroxyl group. The hydroxyl group is polarized into like this. The oxygen is also, and the hydroxyl group is a nucleophile, and it means minus, and it forms hydroxyl group convert into methyl group is converted into hydroxyl group form like this, and converts into R double bond O OH, and it is not occurred because the hydroxyl group is a nucleophile. When the oxygen is written, the methyl group is going outside. When methyl group is going outside, must be converted into nucleophile. It means minus. Okay. When methyl group is converted into outside, the hydroxyl group is added when
Mechanism of this reaction. First of all, sodium hydroxide is going to give you is going to give you hydroxide ions. This is rate determining step. This is acid-base reaction. Acid-base reaction. This is alpha methyl group. This is alpha methyl group which is adjacent to the carbonyl group, which is adjacent to the carbonyl group. CH3 is in acidic in nature. All these protons are acidic. This is acid base reaction. So hydroxide is going to remove a proton from this methyl group to get negative charge. Negative charge here. CH2 gives negative charge. This negative charge is going to induce a partial positive. This negative charge is going to induce a partial positive charge and partial negative charge. This is halogen. This will take one halogen. This will take one halogen replaced by, this is minus X. This will takes one halogen and one halogen. This is halogen. This steps going to takes place 2 times. So sodium hydroxide is going to remove a proton, negative charge, from here. From there is creating a negative charge. From creating a negative charge which can undergo substitution with halogen. This is halogen. So another one more hydrogen got replaced, CH2X2 got replaced CH2X2. So gives CH2X2 again sodium hydroxide. Sodium hydroxide, this is going to remove OH minus. This is OH minus. Replaced OH minus ion to going to remove acidic proton. This OH minus ion is going to remove acidic proton. See, remember, this hydrogen gets more and more acidic substitution the halogens. This is more acidic in nature. Increased much more. We cannot stop the reaction right here because acidity increases very much due to substitution of halogens. Due to the substitution of halogens, this is very acidic in nature. This is very acidic in nature because substitution of halogens takes place. So this is very acidic in nature. We get negative charge here. So carbon gets negative charge. Carbon gets negative charge. This carbon another takes place halogen. This carbon another takes halogen. So we have replaced the hydrogen. We have replaced the hydrogen with corresponding halogen. This is very reactive species. This is very reactive species because presence of more acidic in nature. What happens next? So sodium hydroxide will go to attack the pi bond of carbonyl compound, carbonyl molecule. So carbonyl molecule accepts partially positive charge. So CH3 gets negative charge. CH3 gets negative charge. So increased electronegativity. So increased the electronegativity very much because substituting the halogens. Because substituting the halogens here. So the pi bond polarizes likes, the pi bond polarizes, likes, and attachment of hydroxyl groups takes place. This is CX3. This is CX3 that commit backs this negative this is having negative charge and commit backs CX3 being very.
Now explain applications of haloform reaction. In this reaction, the methyl ketone group is treated with halogen in the presence of NaOH to produce corresponding haloform. In this case, the methyl ketone group is treated with halogen in the presence of NaOH to produce corresponding, and in this case the CH3 group is replaced by OH group to produce haloform, and this is a haloform. In this case, first of all, we are going to in this step to oxidation to convert in this group hydroxyl group or to convert in the ketone aldehyde group methyl ketone to produce methyl ketone. And now to reaction in the presence of NaOH in the treated with halogen to produce the methyl group is replaced by OH group to produce haloform. And this case also same. Methyl group is replaced by OH group to produce haloform. And now in this case the secondary are there. So first of all, we are going to oxidation. Hydroxyl group are converted into ketone group. In this case, the aldehyde group is not directly attached to the methyl group. Methyl group is not directly attached to the aldehyde group. It is a ethyl group, so it is a not formed haloform. In this reaction, it is a not forming of haloform. And in this case, it is a methyl group is, first of all, we are going to oxidation. First of all, we are going to oxidation to produce methyl ketone, and now we are going to treat with halogen in the presence of NaOH to produce corresponding haloform. This now methyl group is replaced by OH group to produce corresponding haloform. And this is a applications of haloform reaction.